looking at question number 2, we are given x as a e to power t of sine t plus cos of t, and y, which is a times e to power t of sine t minus cos of t. So we need to prove that dy dx is same as x plus y upon x minus y. So let us look at how best we can prove that. So to get dy dx, we shall first of all differentiate x with respect to t, and similarly y with respect to t, since x is in terms of t and y is in terms of t. So for dx dt, we shall have this as a is a constant, but we need to look at e to power t and sine of t plus cos of t. Sine of t and sine of t plus cos of t will be one function, and e to power t will be another function. So we shall apply what we call the product rule. We shall apply what we call the product rule. You understand that if you are given d dx of uv, where u and v are functions of x, then you will have u dv dx, then plus v du dx. So we shall do the same. So e to power t will be taken as u, and sine t plus cos of t will be taken as v. So for this case, we shall have a, then we shall be multiplying by. So we shall be multiplying by e to power t, then we shall differentiate sine of t plus cos of t. When you differentiate sine t, you get cos of t. When you differentiate cos of t, you get negative sine of t. Then we shall add there. Next, we shall maintain sine t plus cos of t. In other words, we shall maintain sine t plus cos of t. Then we shall differentiate e to power t. When you differentiate e to power t, it remains e to power t. So that is what we are having. In other words, we shall have this as a times e to power t into cos of t minus sine of t, then plus a times e to power t into sine of t plus cos of t. So from here, we can easily see that this will be same as a times. When we look at the whole of this expression here, a e to power t cos of t minus sine of t, we can easily create y, because y is given as a e to power t sine of t minus cos of t. So it means we can pull out the negative and have negative 1 times e to power t into, so we shall have this as sine t minus cos of t. Then plus, we can easily see that the whole of this is same as x. So let us substitute x here. So this will be same as negative 1 times, we shall see that a e to power t sine of t minus cos of t is actually y. So this is negative 1 times y plus x. In other words, we shall be able to get x minus y as dx dt. So after getting dx dt, we need to get also the differentiation of y with respect to t, since y is given in terms of t. So for this case, we shall say for dy dt. So for dy dt will be same as, we shall use the same. We can realize that y is in terms of t, for which e to power t is one function, and sine t minus cos of t is another function. Similarly, we shall apply what we call the product rule to differentiate this given function. So for that case, let us have our a, which is a constant, and we have e to power t as our u, then sine t minus cos of t as our t. So we shall maintain u this constant, then we differentiate sine t minus cos of t. When we differentiate that, we shall get sine of t differentiated is cos of t. When you differentiate cos of t, you will get minus sine of t. So for that case, it means we shall have minus sine of t. Then we shall add there, maintain sine of t minus cos of t constant, then differentiate e to power t with respect to t. When you differentiate e to power t with respect to t, we remain with e to power t. Then the whole of this is multiplied into a. For this case, we shall get this as a e to power t into, we can write this as cos of t plus sine of t, then plus a e to power t into sine of t minus cos of t. But we realize that this one here, a e to power t into cos of t plus sine of t, is given as x. So we shall have this as x plus this one here is given as y. So this is y. In other words, this will imply that dy dt is same as x plus y. So this will be dy dt, and we already have our dx dt as x minus y. Since we have dx dt, we have dy dt, we can easily get dy dx. So what is dy dx? Dy dx can be obtained as dy dt times dt dx using chain rule. So for this case, what is dy dt? Dy dt, we have it as x plus y. We have it as x plus y. So it means we shall have x plus y times what is dt dx. So we are having dx dt as x minus y. So for this case, it means if we have this as x minus y, then it implies that dt dx is actually same as 1 upon x minus y. So for this case, it implies dt dx will be same as 1 upon x minus y. So this will imply that dy dx will be same as x plus y upon x minus y. And this will be the required answer. We come to question number 3. Question number 3 says the sum of an infinite number of terms of a geometric progression is 15, and the sum of their squares is 45. We are interested in finding the series. So let us look at the solution for question number 3. We are given that the sum to infinity of the terms is 15, and the sum to infinity of their squares is 45. Since we are interested in getting the series, it is very important that we first of all let, for example, a to represent the first term. Let us let a to represent the first term of the series, which is of the GP series, and R to represent the common ratio. To represent the common ratio of the terms. Now, we know from sum to infinity, we know that from sum to infinity, which is same as a upon 1 minus r. This is the formula for sum to infinity, where you have a, which is the first term, divided by 1 minus r, which is the common ratio. That is by definition of what we call a sum to infinity. Now, since we shall be dealing with sum to infinity, it means we shall have to use this definition somewhere. Then next, we need to first of all know the terms. Since we are dealing with an infinite number of terms, we shall let our series to be. Let the series be. Let the series be. We shall let our series to be the first term, which is a. The next term will be ar. The next term will be ar squared. The next term, that is ar cubed. And the terms go like that. So, since we are dealing with an infinite number of terms, we are having as many terms as possible, but we shall have our representation as that. So, remember that we are dealing with a geometric progression, but whose terms are running to infinity. So that's why we are having our common ratio between two consecutive terms being r, since we have stated that r will be our common ratio, and our first term is a. So looking at these terms here, you realize that the common ratio will be the same and will be r. Now let us look at, by definition of sum to infinity, by definition of sum to infinity, which we have put as a upon 1 minus r. So by definition of sum to infinity, which is sum to infinity is a upon 1 minus r, it will imply that for the sum to infinity, we already have 15 here. So it implies that 15 is same as a upon 1 minus r. And for that case, it will imply that a is same as 15 into 1 minus r. We can call this one equation number 1. We also have a relation which relates the terms and their squares. So let us get the squares of these terms here. So the squares will be squares of the terms. Squares of the terms will be, we are squaring each of these terms. So it means we have a squared, we have ar, which will be squared, we have ar squared, which is again squared. We also have ar to the power 3, which is also squared. So our terms run up to infinity. So it means the squares of the terms that we mentioned will be a squared r squared, that is a squared r to the power 4, that is a squared r to the power 6, and they continue in that order. So from these terms here, what will be the first term? The first term is this. First term is actually a squared. And what is the common ratio? What will be the common ratio? The common ratio is actually same as getting a squared r squared divided by a squared. But this one here will give us r squared. So our common ratio is r squared. So by definition of sum to infinity, that is by definition of sum to infinity, what does this one imply? It implies that s dash infinity will be same as a squared, the first term, divided by 1 minus r squared. So this is our common ratio, this is our first term. But we said that sum to infinity for the squared terms will be s prime dash. So that's why we are using this. So for this case, we already have 45 as s dash prime, that is from here, from the given information. Then this will be same as a squared upon 1 minus r squared. So from here, we can have a squared as same as 45 into 1 minus r squared. And this we can call it equation number 2. So looking at the two equations, we have equation 1 and equation 2. We can easily solve these two equations and we obtain the values of a and r in order to obtain our series. So let us look at how best we can solve the two equations to obtain the values of a and r. So we are having equation number 1. From equation number 1 and 2. So these equations where we had a as 15 into 1 minus r. We had a squared, which was 45 into 1 minus r squared. So that is what we had from equation number 1 and number 2. So that is this equation here and this equation here. So those are the two equations that we need to solve to obtain the values of a and r. Now, from these two equations here, we have this one, remember, as equation number 1, this one as equation number 2. So from these two equations, we already have a in terms of r. So let us substitute equation number 1 into equation number 2, where there is a. In equation number 2, we shall simply substitute 15 into 1 minus r. So this will imply that 15 into 1 minus r, the whole of this is a, but a is squared. It will be equal to 45 into 1 minus r squared. For this case, it means 15 squared into 1 minus r squared will be same as 45. This is same as 1 minus r into 1 plus r. So that is basically what we are having there. So for that case, we realize that 1 minus r, one of it will cancel with 1 minus r from here. And for that case, we shall remain with 15 squared into 1 minus r, which is same as 45 into 1 plus r. For that case, we can divide 45 and 15 squared. When you divide 45 and 15 squared, you get 5. So you will have 5 into 1 minus r, which is same as 1 plus r. For that case, we shall have 5 minus 5r, which is same as 1 plus r. So you can correct like terms. You have 5 minus 1, which is 4, which is equal to r plus 5r. So it means 4 is actually same as 6r. So from there, it will imply that our r is 4 by 6, which is same as having 2 by 3. Therefore, r is 2 divided by 3. So you have r, but we also need a. So from equation number 1, it will imply that a will be same as 15 into 1 minus 2 by 3. And this will be 15 into 1 by 3. And this will give us a as 5. So we shall have our a as 5. So what will be the series? Therefore, the series is, recall that we had read our series to be ar squared, ar cubed. So we shall substitute for the values of a and r. So substituting for the values of a and r, what do we get? So it will imply we shall have a, which is 5. We shall have a, which is 5. Then the next term was ar, that is 5 times 2 by 3. The next term was ar squared, 5 times 2 by 3 squared. And it goes on like that. So in general, we shall have our series as 5, 10 by 3. This is 5 times 4 divided by 9, that is 20 by 9, and our series continues like that. So this one here will be the required series.